Our learning target is I can graph a quadratic function in vertex. So what do you need to know? Vertex form looks like f of x equals a times the quantity of x minus h all squared plus k. H comma k is the vertex. Notice in the equation that the h has a subtraction sign with it. So what this means is that when you pull out your value of h, it's going to be opposite whatever sign you have in your given function. So if I'm given a negative, my h is really positive. If I'm given a positive, my h is really negative. So another way of looking at it, you're going to change the sign for h, and k, you do as it says. So keep the sign. Something that I learned from my math teacher was that he called H Hank and K Kelly, and Hank lies and Kelly tells the truth. That was a little fun way to remember that you change the sign for H and you keep the sign for K. Now A out front, just like in standard form and in factored form, tells us if the parabola opens upward if it has a minimum, or if it opens downward and has a maximum. Remember, if it opens upward, A is positive, and if A is going to open, or if my parabola is going to open downward, A is going to be negative. Since the axis of symmetry always passes through the vertex, the equation of the axis of symmetry is just x equals h. So this one's pretty easy to identify. There's no formula. Whatever your value of h is, that is going to be your axis of symmetry. So let's look at how we graph from vertex form. Step one is to determine the coordinates of the vertex and plot the point. So we find our h and our k first. Then we draw in the axis of symmetry as a dashed line. Third, we determine two other points on the graph, and I'll show you how to do that. We plot one and then the mirror image. Remember that the axis of symmetry shows us like the middle of the parabola, and what's on one side is going to be true in the mirrored image on the other. And then we go ahead and sketch our. So let's take a look at those steps. So we're going to go ahead and find our vertex first. Remember my little analogy, Hank lies, Kelly tells the truth. So since my h value is a positive 3, my h is really going to be a negative 3. Kelly tells the truth, so my plus 1 stays plus 1. So my vertex is at negative 3, comma 1. Remember my axis of symmetry, we just pull out the h value, or that x coordinate, from the vertex, so h is just negative 3. These will always match. So whatever your vertex is for your x coordinate, that is what your x is going to equal for your axis of symmetry every time. Will I open up or down? Since I have really nothing in front here, there's no number, that really means we have a 1. So that's a positive 1, meaning that it's going to open upward. So it's going to look, this is what I mean when it opens upward. That also tells me that I'm going to have a minimum value. And then other points. So if I want to determine some other points, this is what I would do. I always usually choose 0 and 1 because those are the easiest numbers to work with. So for this, when I was choosing 0 for my value of x, I just picked 0 because it's easy, and I plug in 0 into my equation. Okay, so here's my function. I'm plugging 0 in for x. So 0 plus 3 is 3. 3 squared is 9, and 9 plus 1 is 10. That is where this 10 is coming from. Okay, so that's that first point, 0, 10. Now for my x value of 1, we did the same thing, except we evaluated my function at 1. So I'd have 1 plus 3 all squared plus 1. And when I evaluate this, I'm going to have 1 plus 3, which is 4. 4 squared is 16, and 16 plus 1 is 17. So that's where that 17 is coming from. So now, I want to graph this. We have the entire image graphed here, but I'm going to show you step by step how we did it. So we started with that vertex. So that was my part here in purple. Okay, and that's our first point that we're graphing. So we're going over -3 and up 1. That's where that point is coming from. My axis of symmetry goes through at that point on the x-axis. Okay, so that's where my dashed blue line is. And then I pick my other points. Okay, so we found the point at 0, 10. So when I went to graph 0, 10, okay, that actually happens to be my y-intercept as well. Since that is 1, 2, 3 spaces away from my axis of symmetry, if I go 1, 2, 3 spaces away on the other side, I'm going to get to my other point on the parabola. Okay, because they're just mirror images of each other. And we did the same thing for 117. So I went over 1, up 17, so that's where I got this guy up here. And then now I'm 1, 2, 3, 4 spaces away from my axis of symmetry. So I have to go 1, 2, 3, 4 on the other side. So there are my points, and then I'm able to draw in my axis of symmetry. Of course, mine's not nearly as neat as when the computer graphed it, but you get the gist. So it's in that U shape, and I have all of my points identified. I'll make them a little bit bigger for us here so we can see those points there on the parabola. Okay, so all right, so we're at example 2. You can go ahead and pause, try this one, and come back to check. Our function this time is f of x equals negative times the quantity of x plus 3 all squared plus 5. So if you'll remember, when I'm finding my vertex, I'm looking for h and k. Okay, and my h is the opposite sign, Hank lies. So since I have a positive 3 in here for my h, it's really going to be a negative 3 when I pull it out. And then my plus k just stays whatever sign I have. We keep the sign for k. Now my axis of symmetry is going to be the same value as my h. Since I had a negative 3, x is going to be equal to negative 3. That one's pretty easy to pull out if it opens up or down. So I'm looking at that value out front. Okay, that a value is out front here. And this time I have a negative. That would really be like I have a negative 1 since there's no coefficient there. There's really a 1 there. So it's going to open down. And since it's opening down, this tells me that I'm going to have a maximum value to my parabola this time. Now, when I am picking my other points, this one's going to be a little bit, last time we picked 0 and 1, but we don't want to necessarily pick 1 this time because it would be a little bit more difficult to graph. So this time I picked 0 and negative 1, and I'll show you why I went with a negative 1 instead of positive 1 in a minute. But I'm going to start here with the 0. So we usually always use 0 just because it's easy to use. So if I'm evaluating at f of 0, I'm going to have negative and then 0 plus 3 all squared plus 5. So when I evaluate this, when I use that PEMDAS parentheses, I've got 0 plus 3 is 3, 3 squared is 9, but it's negative. So negative 9 plus 5 is going to give me that negative 4. That's where that negative 4 is coming from. Okay, now before I show you how I evaluate at negative 1, I'm just going to talk about the graph here for a second, and then I'll come back to why I chose that point instead. So my vertex this time is at negative 3, 5. Okay, so I went over negative 3 up to 5, and that's where we're getting this maximum point there of my vertex, where that parabola is going to start opening down in either direction. My axis of symmetry runs through that point at x equals negative 3. Okay, so that's where my axis of symmetry is coming from. That's where that dashed line is coming from. And my other point, so when I picked 0 to start, I got 0, negative 4. So when I went to graph that, 0, negative 4 came down here, and that was 1, 2, 3 spaces away, so I go 3 on the other side, and that's how I'm getting that second point on the other side of the axis of symmetry. They're always going to be symmetrical, the same distance away from the axis of symmetry. Now, instead of going to positive 1 and finding that point way down here, I decided to move backwards and use negative 1 because it's closer to my vertex. So using 2 points close to your vertex can really make a difference in terms of your graph. You won't have like some crazy numbers where you're plotting points way down your parabola. So choosing points closer to your closer to your vertex are going to be easier to graph. So at -1, when I evaluate that, I'll show you where that 1 is coming from. So we have negative and then -1 plus 3 all squared plus 5. -1 plus 3 is 2 and 2 squared is 4, but it's negative out front. So -4 plus 5 is +1. So that's where I'm getting this +1 from. So when we go and graph that point, -1, 1, that's where we get this coordinate here, and it's 1, 2 spaces away from the axis of symmetry. So I go 1, 2 on the other side, and then we draw in our parabola. Okay, so that's where all of that's coming from. All right, so that learning target of graphing in Vertex Form. If you need more information on this topic, you can check out the learning target spreadsheet for additional resources, videos, and practice.